All of you are aware that Earth's natural calamities include earthquakes, tsunamis, volcanic eruptions, cyclones, floods and landslides. Whenever such natural calamities occur, there will be a severe loss to both life and properties. Landslides are the regular natural hazards experienced in the hilly and mountainous areas all over the world. Frequent occurrences of landslides have been recorded by many countries throughout the world. Landslide is a general term used to describe the downslope movement of soil, rock and organic materials under the effects of gravity and also the landform that results from such movement. Varying classification of landslides have been proposed in association with specific mechanics of slope failure, properties and characteristics of failure types. Hence, it is necessary to understand the following aspects of landslides: landslides as natural hazards, causes of landslides, classification of landslides, landslides and other hazards, effects and evaluation of landslides. Hills and mountains are typical geomorphic features. They are characterized by gentle or steep slopes. Sometimes they may have cliff like vertical slopes. They are all called as hill slopes. The hill slopes are typical geomorphic conditions. They are unique climatic zones. They are characterized by thick soil profiles, richness with soil moisture and plant growth. Landslides normally occur on the hill slopes. When the slopes are stable, there will be no problem. When the slopes become unstable, then they may lead to the occurrence of landslides. Landslides occur when the stability of the slope changes from a stable condition to an unstable condition. The change in the stability of a slope may happen due to several factors. These factors may be acting alone or may be acting together. Hill slopes have a very good drainage of rainwater. The bedrock configurations also vary very uniquely. The subsurface conditions of a hilly terrain may have two distinct zones as overburden and the basement rock. The overburden may be mostly loose soil, may have a thick weathered zone with adequate natural or man-made vegetation, may have good root penetration, and all are available under the direct influence of climatic variations, especially the role of rainfall. Occurrence of landslides also change the general landscape or the geomorphic conditions of a region. The topography and drainage get modified due to these hazards on the hill slopes. Landslides can destroy the forest and other natural resources. Landslides will also damage the man-made structures like roads, railways, tunnels and buildings on the hilly regions. The study of landslides helps in identifying the weak zones, classifying the hill slopes into different categories and to minimize the impacts of landslides in those regions. The bedrock is related to the basement rock of the hill. These may be very massive or fresh or structurally weak or structurally strong or structurally deformed rocks. All of these may be under the influence of a tectonic force originating from the deep interior or a nearby huge structure like a dam. The next factor is the degree of slope on the hills. Slope is the common factor for a landslide. The categories of slope is to be understood first. The term slope here refers to the angle of inclination of the land surface. It varies depending upon the geomorphic conditions, bedrock configurations, nature of the overburden, the presence of vegetation and the nature of the drainage network or systems available on a place. The following are the categories of slopes recognized in different places. If the slope is greater than 80 degrees, it is called as a cliff. If the slope is ranging from 50 to 80 degrees, it is called as a precipitous slope. If the slope angle ranges from 20 to 50 degrees, we call it as very steep slope. If the slope angle varies from 6 to 20 degrees, we call it as a moderate slope. If the slope angle varies from 1 to 6 degrees, we call it as a gentle slope. If the slope angle is less than 1 degree, it is not a slope, but it is a flat terrain. There is an engineering classification of slopes which is related to only two categories as stable slope or unstable slope. According to engineering principles, a slope may be a stable slope or an unstable slope. The hill slopes may be stable or unstable. The slope instability comes due to the relations between the overburden and the nature of the bedrock. It also depends on the limiting angles which control the geomorphic processes which are acting on it. Stable slopes are below the limiting angle for mass movements. They are normally ranging from 38 to 40 degrees. Slope instability comes due to the geological, geomorphological and hydrological conditions in a mountainous region. These include hill slope processes, changes in vegetation, land use practices, human activities, frequency and intensity of precipitation and local seismicity if available or present. Landslides are caused due to several factors. Some may be natural and some may be human induced factors. The natural causes of landslides include change in the hydrological conditions, that is one. The groundwater pressure may be acting to destabilize the slope. Change in vegetation is another important factor. There will be loss or absence of vertical vegetative structure, soil nutrients and soil structure due to forest fires or due to mining activities. Removal of surface mass is another important factor. The erosion of the toe of a slope by running water or rainwater may be responsible for the occurrence of a landslide. Snow melt is another important factor for landslides. Weakening of a slope through saturation by snow melt, glacial melting or due to heavy rainfall will be a responsible factor for the occurrence of landslides. Seismically induced changes may also trigger the mechanism of landslides. The occurrence of microseismic waves or tremors may be inducing the occurrence of landslides. In some parts of the world, volcanic eruptions are also the causative factors for the occurrence of landslides. The geological factors influencing the landslides are the continuous rainfall, that is heavy rainfall, slope beyond the limiting slope, soil type, thickness of the soil profile, bulk density, the nature of permeability and moisture content available, the soil flowage, increase in soil moisture, the plasticity index of the soil conditions, all are responsible for the occurrence of landslides. Vegetation plays a dominant role in the occurrence of landslides. It has both positive and negative impacts on the slopes. The factors influencing are the density of vegetation, the type of vegetation, the canopy and weight of the vegetation, the root penetration, the age and life of vegetation, and the rejuvenation of the forest conditions. The overland flow of water is an important factor. It plays a dominant role in the occurrence of landslides. In fact, water plays the major role in the origin of landslides. The factors which are responsible for the occurrence of landslides are heavy rainfall, which will be inducing more percolation of water, then increase in the level of saturation of the subsurface soil horizon, and also the drainage patterns which are existing in a place, the stream frequency and the stream density which are available on a slope will be playing a significant role. When water infiltrates, a slippery phase is created above the bedrocks, and that will be creating the mechanism of sliding. There are certain morphological causes for landslides. They include the tectonic or volcanic uplift, the glacial rebound, the fluvial wave or glacial erosion of the slope or lateral margins of these features, the subterranean erosion, that is the solution activity, then deposition, loading effect on the slopes, all of them are responsible. Then if people remove the vegetation by forest fire or continuous failure of monsoons, that will also create more infiltration of water and also subsequently creating the landslides. The thawing is one important mass wasting activity, weathering activity, which will be creating a loose soil, which will be encouraging the percolation of water and encouraging the occurrence of landslides. Although landslides are primarily associated with mountainous regions, they can also occur in areas of low relief also. In low relief areas, landslides occur as cut and fill failures, the river bluff failures, the lateral spreading of landslides, the collapse of mine waste piles. A wide variety of slope failures are associated with quarrying activities and open pit mining activities, and that is what we might have seen in so many places in so many countries. So, landslides are also caused due to several such human activities. The other major human causes include deforestation and cultivation, disturbing the drainage patterns through cut and fill operations, construction activities, blasting activities, mining and quarrying activities. Vibrations from machinery which we use on the slopes, or heavy traffic in a particular place after the rainfall, and movement of heavy vehicles on the slopes, on the guard sections nearing the slopes will also increase the weight. The earthwork which alters the shape of a slope and impose new loads on the existing slopes may also trigger the landslides. Removal of deep rooted vegetation will be a cause for the landslides. The forest fires or bush fires and clearing of trees will also induce more percolation and also the occurrence of landslides. Landslides are classified into various types based on the nature of the material involved and the type of the movement involved. Based on the nature of materials involved, landslides are classified into rock slides, debris slides, earth slides or landslides. Based on the type of movement involved, landslides are classified into falls, topples, slides, spreads and flows. Slides are typical features. Although many types of mass movements are included in the general term landslide, the more restrictive use of the term refers only to mass movements where there is a distinct zone of weakness that separates the slide material from more stable underlying material. The two major types of slides that are identified are the rotational slides and translational slides. Rotational slide is a slide in which the surface of rupture is curved concavely upward and the slide movement is roughly rotational, but an axis that is parallel to the ground surface and transverse across the slide happens. In a translational slide, the landslide mass moves along a roughly planar surface with little rotation or backward tilting. Rock collapse are also sliding events of rock masses on an irregular rupture surface, and these may be consisting of a number of randomly oriented jointing patterns. Rotational soil slumps are sliding actions of cohesive soil masses on a cylindrical or ellipsoidal rupture surfaces. They also show little internal deformations. Debris slide is also a sliding of a landmass of granular material on a shallow planar surface parallel to each other with the ground. And the next one is the falls. Falls are abrupt movements of masses of geological materials such as rocks and boulders that become detached from steep slopes or cliffs. Separation occurs along discontinuities such as fractures, joints and bedding planes, and movement occurs by free fall, bouncing and rolling actions. Falls are strongly influenced by the action of gravity, mechanical weathering and the presence of interstitial water. Topples are typical landslide occurrences. A topple is the forward rotation out of a slope of a mass of soil or rock. It happens around a point or axis below the center of gravity of the displaced mass. Toppling is sometimes driven by gravity exerted by the weight of the material present upslope from the displaced mass. Toppling failures are distinguished by the forward rotation of a unit or units above some pivotal point below or low in the unit under the actions of gravity and the forces exerted by the adjacent units or by fluids which are present in the cracks. Flows are important downslide movements. There are 5 basic categories of flows that differ from one another in the fundamental ways. They are debris flows, debris avalanches, earth flows, mud flows and creeps. So, these are all the 5 major types of flows which we have identified in different places. A debris flow is a form of rapid mass movement in which a combination of loose soil, rock, organic matter, air and water mobilize together as a slurry and that flows down the slope in a hilly region. Debris flows include less than 50% of fine grained mass. Debris flows are commonly caused by the intense surface water flow due to heavy rainfall or precipitation or rapid snow melt that erodes and mobilizes the loosely available soil or rock on the steep slopes. The next one is debris avalanches. This is a variety of very rapid to extremely rapid movement along the slopes. The next one is the earth flow. Earth flows have a characteristic hourglass shape. The slope material liquefies and runs out, forming a bowl or a depression at the head. The flow itself is elongate and usually occurring in fine grained materials or clay bearing rocks on moderate slopes and also under fully saturated conditions. Mud flows are yet another types of landslides. A mud flow is an earth flow consisting of material that is wet enough to flow rapidly and that contains at least 50% sand, silt and clay sized particles. Creep is yet another landslide movement. Creep is the imperceptibly slow, steady downward movement of slope forming soils or rocks. The movement is caused by shearing stress sufficient enough to produce permanent deformation, but it will be very small to produce shearing failures. Landslides are much related to the influence of water, and oversaturation of soil mass with water on the slope areas is a primary cause of landslides. This effect can occur in the form of intense rainfall, snow melt, changes in groundwater cycles and water level changes along the coastlines, earth dams and the banks of lakes, reservoirs, canal and rivers. Landsliding and flooding are closely allied because both are related to precipitation, runoff and the saturation of ground by water. In addition, debris flows and mud flows usually occur in small steep stream channels and also often are mistaken for floods. In fact, these two events often occur simultaneously in the same area. Landslides are also related to seismic activities. Many mountainous areas that are vulnerable to landslides have also experienced at least moderate rates of earthquake occurrences in the recorded times. Landslides are also related to volcanic eruptions. Landslides due to volcanic activity are some of the most devastating types of landslides which we have seen. Volcanic lava may melt snow at a rapid rate, causing a deluge of rock, soil, ash and water that accelerates rapidly on the steep slopes of volcanoes, devastating the materials, houses, settlements or anything along their path. Landslide mitigation is an important aspect of disaster management. How to reduce the effects of landslides is coming under the landslide mitigation activity. The vulnerability to landslide hazards is a function of location, type of human activity, use and frequency of landslide events. The effects of landslides on people and structures can be lessened by total avoidance of landslide hazard by restricting, prohibiting or imposing conditions on the landslide hazard zones of the area. The hazard from landslides can be reduced by avoiding the construction on the steep slopes and also the controlling the existing landslides by stabilizing the slopes. Landslide effects occur in two basic environments. One is the built environment, another one is the natural environment. Sometimes there is intersection between these two. For example, agricultural lands and forest lands that are logged are coming under joint environments or combined environments. The effects of landslides on the built environment has to be properly understood to curb the effect of landslides. Landslides affect man-made structures whether they are directly on or near a landslide. Residential dwellings built on unstable slopes may experience partial damage to complete destruction as landslide destabilizes or destroy these foundations. Walls will be collapsing, the surrounding properties will be damaged above the ground and also sometimes underground pipelines, everything will be damaged due to these landslides. One of the greatest potential consequence of a landslide is the transportation industry. The effect of landslides on the natural environment has to be understood. The morphology of the earth's surface, especially the mountain and valley systems, both on the continents and beneath the oceans, will be affected due to the occurrence of landslides. The mountain and valley morphologies are most significantly affected by the downslope movement of large landslide masses. The forests and grasslands that cover much of the continental regions will be affected. The native wildlife will also be affected due to the landslide occurrences. Forests, grasslands and wildlife often are negatively affected by landslides, with forest and fishing habits being most easily damaged and also destroyed. Technological tools for the evaluation of landslides are available. Mapping, remote sensing and monitoring are the major technological tools which are available for analyzing and evaluating the landslides. One of the guiding principles of geology is that in evaluating landslide hazards, The future slope failures could also occur as a result of the same geological, geomorphological and hydrological situations that led to the past and the present failures. Based on this assumption, it is possible to estimate the types and frequency of occurrence, extent and consequences of slope failures that may occur in the future along the slope. So, geology helps to understand the future occurrences of landslides. The human induced conditions such as changes in the natural topography or hydrological conditions can create or increase the susceptibility of slope failures and also increase the occurrence of landslides. Useful conclusions concerning the increased probability of landslides can be drawn by combining the geological analysis with knowledge of the short term and long term meteorological observations also. Map analysis is one more tool. Map analysis is usually one of the first steps in a landslide investigation. Necessary maps include bedrock and surface geology, topography, soil maps, geomorphological maps. All these maps can help in identifying the landslide prone areas. Using the knowledge of geologic materials and processes, a trained person can obtain a general idea of the landslide susceptibility from such maps. Aerial surveys are also helpful to detect the occurrence of landslides. Analysis of aerial photography is a quick and valuable technique for identifying the landslides because it provides a three-dimensional overview of the terrain and indicates the human activities as well as geological information to a trained person. In addition, the availability of many types of aerial imageries or satellite imageries makes the aerial surveys very effective, versatile and cost effective to identify the areas of landslides. The field surveys are also very important tools. Many of the more subtle signs of slope movements cannot be identified on the maps or aerial photographs. So, field surveys are very essential. Indeed, landslide features change over the time on an active region. Field occurrences is always mandatory to verify or detect the landslide features. It is also needed to critically evaluate the potential instability of vulnerable slopes in the hilly regions. It identifies the areas of past landslides by using the field mapping and laboratory testing of the terrain through the sampling of soils and rocks. Geophysical studies are also useful for this purpose. Geophysical techniques can be used to determine some subsurface characteristics such as the depth to the bedrock, stratigraphic layers, zones of saturation and sometimes the groundwater table. They are also used to determine the texture, porosity and degree of consolidation of subsurface materials and the geometry of the units involved. By understanding of the impacts and causative factors, we can minimize the effects of landslides and we can even control the slope failures. The knowledge of geology of the region is essential for mitigating the effects of landslides. You are all aware that geology illuminates the past, sustains the present and promotes the future. In this case, for understanding the past occurrences of landslides and predicting the future occurrences of landslides, geology is more helpful. Let us understand the geology of hill slopes.